Any development of a vehicle starts with a beautiful concept of what that vehicle looks like, and it's our job to turn that into a vehicle.
So we build attribute prototypes actually quite early in the design phase. So we design on computer, but there are certain aspects of that design that we can only test and verify in the real world. We will build around 20 prototypes here. About 7 of them will not drive. They're just statically tested. And those we will test high-speed crash and low-speed crash performance, and also structural durability.
Part of the process of doing this activity is to understand how the vehicle goes together. So you start from a series of parts, you put those parts together, but the action of putting them together is part of our learning. And there are things that we find during that process that go well and don't go well. But the intention is that therefore we're confident you can build it and it will perform. And those things are very joined together in terms of the process. So, as you can see, the front fender is not made of a production representative material, and we have visible fasteners that you wouldn't have on a production vehicle. But what it allows us to do is represent the shape, represent its function. The windscreen is a fully representative material because we need it for testing, and also the door is. The door is aluminium, as we will use in production, and that's because we need the door to function as the door would function on a production car.
Here we're using bonded aluminium. It delivers something of more flexibility in the different vehicles it can produce, but also it gives you much higher stiffness, which is a key criteria to deliver vehicle dynamics.
So typically we would dry fit the part first, just to make sure everything lines up as it should be, there's no unexpected errors, because the last thing you want to do is glue it all together and something's wrong.
Bonding is done with an epoxy resin. The glue that we use when the joint is made is actually stronger than the aluminium to which it's attached.
There are other people who've done this in the past, but we are taking it to the next level.
So the rivets are purely to hold the panels in place whilst the glue cooks. Once the car is cured, we don't need them, but we need enough to ensure that the parts remain clamped in the oven. It's a bit like when you go to the doctors with a broken leg. They'll set a pin in the leg, but once the bone is healed, the pin doesn't bear any weight.
So here at this stage of production, everything is very manual. So we apply glue more or less manually using certain tools, and then cure it in an oven, and that curing process sets the glue and delivers the structural strength that we finally have. In production, this will all be done robotically.
One of the things about putting a concept car into production is about our interaction. It was not like a car was delivered and we then needed to turn it into something real. Our relationship with Nahum and Max and the others in the team is really important. So how the occupant sits and where they sit and why they sit, and how that relationship between the product and the finished vehicle and the concept are all connected. An attribute prototype vehicle like this is not actually a fully representative production vehicle. But the important thing is that we learn specifically what we've decided we want to learn and need to learn in order to progress through the process of the program.